very good day to one and all. Welcome to our ISS Learning Festival 2020. This talk is about creating health impact through applied research at ISS. Let me now introduce my team and myself. So I am Dr. Matthew Chua. I'm currently a faculty at NUS Institute of System Science at the Squamous School of Public Health. I'm also a resident fellow at NUS Cambridge Hall. My research interest actually spans in medical systems, robotics, and AI. And I'm currently heading the research in ISS and a principal investigator of over $1 million worth of research funding in AI and health. On the side, I'm also a professional opera singer. Okay, Mr. Ko Wai Kin is a second speaker, and he is actually my research engineer in the Smart Health Leadership Center, NUS Institute of System Science. He specializes in intelligence sensing systems and software, and is a full-stack software engineer. Ms. Li Mengyuan is my third speaker, and she is a research nurse and a research engineer at the Smart Health Leadership Center, NUS-ISS. She specializes in healthcare application and biostatistics. She is she's very established in the knowledge of in the medical field, as she was a nurse for quite a number of years in the health sector before joining us. Now, let me talk more about NUS-ISS. NUS-ISS is an industry-oriented, practice-based institute in NUS, and we are 39 years old this year. Our core strength and capabilities lies in applied research, numerous industrial collaboration, and also in education and training. Our three key pillars of expertise is in software engineering and design, intelligent systems, and in business analytics. We come from a sub-department in ISS called the NUS-ISS Smart Health Leadership Center, whereby our vision is to transform the future experience of health through data, tech, and design. Right? So we actually specialize in applied research, the running of executive courses and Master of Technology courses. All right. And also, we do consultancy and as well as whole community of practices. So the agenda for today's talk, okay, will be in three parts. Okay, the first part will be covered by myself. I will give an overview of the ISS applied research projects for health impact. Then, following which we have Wai Kin, who will be covering the intelligent stroke rehab system. And then lastly, we have Meng Yuan, who will be touching on the melanoma detection application, which is a prototype that we are currently developing. Okay, so some envisioned scenarios in 2030. First will be the cyborg reality. Okay, we will see greater integration between humans and machine. So you can see in the picture, this is the bicentenarian man from the movie. All right, where you will see that more and more synthetic smart organs or biochips will be replacing the parts within human beings, okay, to enhance and to take over certain parts of the human functionality. So these chips can also effect mood changes, improve cognition or memory in human brains, or even within the body functionality. Okay, and then you will also be able to monitor life and support life. All right. Next, we have one small world, okay, whereby we'll see how the world will transform in terms of communication. So people have asked, when will our current smartphone craze or period phase out? So the answer to that will be whereby we have smart contact lenses. Okay, so this smart contact lenses actually utilizes AR, augmented reality, okay, to provide information to users. So now I could be lecturing a class of 50 students, and I could be, looking at lecture slides, that is being projected in mid-air, or watching YouTube video, and also replying to WhatsApp messages. Okay, all within my contact lenses, and this will be oblivious to people around, right? So this will greatly improve human productivity as well, as now humans can multitask more efficiently. So this also will revolutionize languages, in the sense that let's say, for example, if I were to go to Japan, I do not know Japanese, but I could be speaking to a Japanese person, and as a person replies to me in Japanese, I will be able to see subtitles appearing underneath him, right? and then I'll be able to reply to him, and then he will be able to see subtitles in Japanese appearing underneath myself, and then this will definitely create a seamless communication between people of different races, different communities, and different languages. Okay, so now we will come on to the more interesting part on the NUS-ISS digital health project for the community. Right, the first will be the mHealth Fine Motor Skills Rehab for Stroke. Okay, this project will actually be covered more in depth by Mr. Ko Wai-Kin later. So I'll just touch on it briefly. So this project is funded by Tote Board and supported by SG Enable, and it's a collaboration between NUS-ISS and Stroke Support Station. Okay, so the first one, post-stroke, is the most critical period, okay, for stroke survivor to regain their motor skills, right? So if you do not focus on your recovery during the first 6 months after you've gotten a stroke, then after the 6 months, you'll probably be stuck with that level of mobility, all right? So the sad thing is that most patients cannot afford time or money for the daily rehab that is ideal. So therefore, they are not regaining back the best motor skills they can. Furthermore, there's a shortage of therapists currently, and then therefore this results in the wide amount of spacing between your appointments. Probably you can only see a therapist once a week, okay, in such a instance. Okay, the recovery of the fine motor skills of hand also yet cannot be tracked. So let's say in day 1, if I go for rehab, I only can move 1 degree of my joints. In day 7, I can move 5 degree. Okay, this cannot be quantified currently. Everything is just based on a visual inspection of the therapist. All right. So the summary of the project is that, okay, we have developed a mHealth hand rehab system for stroke patient recovery that integrates infrared-based camera tracking and machine learning, games, and a virtual AI instructor. Okay, this is able to capture every finger joint of the hand and find range of motion data. It's fun and easy to use, and is able to track the adherence to program. Okay, so this system was unveiled during the opening of the Stroke Support Station branch at Jurong Point in May 2019. Okay, so we have been covered by Channel News Asia. You can watch the YouTube video when you are, if you are interested. Okay, so these are some pictures of what the system looks like. It's in a very portable, slim form factor of a tablet with camera mounted on it. Okay, this allows the patient or the survivor to use the system anywhere they would like, and then you can see that there's also AI instructor in the form of a bear that to cue you or to give you instructions. Okay, and then we have games like the fishing game, bird games, monkey games, and we are currently adding more games to the library so that users can try out different games and not feel bored. Okay, and we also have an assessment summary that is produced to the user after each session, right? And this gives the therapist and the user a more objective indication of their recovery rate. Okay, next we go on to the iGait device for elderly with walking dysfunctionalities. Okay, iGait stands for Intelligent Gait-Assistive Device. So currently, the older you get, right, your motor skills decline. Okay, so this is all you know as psychomotor, right? And then you will find sometimes you'll find it difficult to walk down the stairs or walk up the stairs because halfway through your mind lost track of which leg you are at. Okay, so we have developed an iGait device that acts as an intelligent sensing and learning system that is worn on the ankle of the elderly that provides biofeedback through electrical stimulation. So the elderly will feel electrical sensation on the leg. So how this works is very similar to the heart pacemaker, right? So the pacemaker of the heart actually provides the pacing of the heart through electrical signal as well. So this iGait provides the pacing of the leg through electrical signals sent to the leg, right? So the system is able to detect when the elderly moves off, and then the pace of the elderly, and then in order to maintain the pace, the system will send electrical signal to each of the 2 legs, and then as and when the elderly need to focus on the leg to swing or to move the leg, right? And if the elderly slow down, the system will also modulate its frequency accordingly. Okay, so this allows the elderly to coordinate the movement better, and this is especially so for those who are suffering from Parkinson or certain other kind of psychomotor dysfunction. So the benefit is that this frees up the healthcare or caregiver time and energy, because this makes the elderly more independent, empowers them, builds confidence, and improves mobility. So it's also more effective than current methods whereby they use audio or metronome to actually cue the elderly. All right. So through sensation is more apparent and to the elderly than through audio stimulation. Right. And then this one can be worn under the pants of the elderly, such that to make it inconspicuous to those around. Okay. This project is was funded by NMRC, and then we have actually successfully completed the pilot study on about 50 elderly, which shows the potential of them having improved walking functionalities. Okay. Next, we have a mind tapping interface for lock-in syndrome patient, LIS patient. So lock-in syndrome patient or LIS patient are patients who one day wake up, right? And then you find that your entire body is paralyzed. The only thing you can do is you can look around with your eyeball and you can breathe. Okay. These lock-in syndrome patients typically stay in the state for about 20 years or more. So you can imagine the amount of agony and torment they face in their daily living, all right, and the amount of resolve. So we have actually developed a 3D printed EEG headset that they can wear, right, to allow them to type out their thoughts. So currently they cannot communicate. So the only way to communicate currently is that whereby the nurse comes or the caregiver comes with a list of questions, and they will ask the patient, say, if you are thirsty, look left. If not, look right. And then if you're hungry, look left. If not, look right. And then so on and so forth. They go down the list. So by the time the nurse comes to the question that is pertaining to the patient, right, night has turned to day, right? It takes very, very long. And then this builds a frustration in the patient. So this system basically can be worn and allows the user to type out their thoughts, right? So the user can focus on A, and then the alphabet A will pop out on screen, for example. All right, and then they can customize their messages. They can say, "No, mom and dad, I love you," or "I miss my dog," or so on and so forth. Right? It's basically a hands-free, mind-driven typing interface. Okay. So in here I have the video YouTube link that you can watch if you are interested. It's filmed by my student, okay, who actually demonstrated the use of the device to type out the word NUS. So the typical cost of an EEG headset outside costs about 80 over K. All right, but we are able to develop one at a fraction of the cost at only about $5,000. All right. The next one I will touch on is actually large-scale hospital vitals monitoring. Okay, this is in collaboration with Providence Solution. So currently, nurses have to wake patients up every 2 to 4 hours to collect vital signs like blood pressure, heart rate, etc. All right. So this is a manpower-intensive and redundant task. Okay, this causes inaccuracies in the entry of data in systems because they usually write on paper. Okay, and disturbs the patients. Furthermore, patients will usually venture around the hospital ground, and they may fall in other parts of the hospital, which goes unnoticed. Okay, and this may pose problems. So we have actually produced a prototype system, okay, that allows for the wide-scale monitoring of such patients. So the patients, currently patients that enter the hospital, that they are tagged with a dumb tag, okay, whereby the tag only records their name, maybe their blood type, and also their food preferences, for example. All right, it doesn't do any sensing or stimulation or whatsoever. Okay, so this tag that we are proposing is a smart tag, okay, and it will be tagged to each patient upon admission. And once you are tagged, you are being monitored, okay, during your stay in the hospital. Your vitals are being pushed into the system. Okay, we measure things like your heart rate, your skin temperature, and also your SpO2, and then also your whereabouts. So this is actually measured through the use of a mesh network, okay, by Bluetooth. So the mesh network actually allows for the triangulation of the person's location at any time during their stay in the hospital. So if they say the uncle go down to the kopitiam and falls down there, okay, the nurse will be alerted to it immediately, and then they can send their assistance, quickly. So these are the features and benefits. All right. So disposable tech. Okay. So it's meant to be disposed once you are discharged. Okay. Updated every 10 minutes. Okay. And then we are looking to partner hospitals to trial it in Singapore. So this gives faster responses to incidences, manpower savings, and also better quality of hospital stay. Next, we have a community-based cardiac rehab. Okay, this is a project in collaboration with Alice Lee Center for Nursing Studies, whereby we are looking at the development of an integrative cardiac rehab employing smartphone tech, okay, or iCRES. So how this works is that, okay, once a patient has undergone heart surgery, we are trying to discharge the patient as soon as possible into the community to do the rehab there. This will free up hospital space and hospital resources. Okay, so how to do it safely is that we are going to develop a home-based cardiac rehab tech using IoT technology that allows for active tracking of vitals while patients perform the exercises. Okay, this app also has educational components, monitoring, and active feedback. Okay, and we are looking to trial this as a pilot study in a hospital next year. Okay, at NUH. So the benefits is that, okay, it's cost saving for patients and hospital, faster discharge rate, better tracking of adherence, and we can quantify the patient recovery. Okay, so I'll just quickly go through the other research work that we are also currently involved in or have done. Okay, one is that we have developed AI systems to predict dengue from data, and we have published this in the Journal of Health and Social Sciences. I think this can be quite useful for Singapore, especially now we're combating a spike in dengue cases. Okay, how to detect surges in dengue hotspots, okay, through climatic and terrain data using ensemble of multiple predictive models. Okay, next we also have published in the Journal of Cells, okay, whereby we have developed and proposed a deep recurrent neural network model to identify DNA enhancers. Okay, so this also allows for the study of DNA traits and characteristics. Okay, we also have done TB diagnosis through medical images. Okay, and then this has been published also in a conference last year. Okay, whereby we visualize regions of the chest X-ray, right, that resembles the tuberculosis, and then this can lead to automated diagnosis and identification. And then, so similarly, we have done so for diabetic retinopathy, whereby we have also published in the conference last year. Okay, using a BiraNet, right? It's a special machine learning model. Okay, and this has have shown superior results. Okay, in terms of classification of retina. Okay, so my advice to all of you out there, right? Follow your passion. Make sure your passion can feed you also. Remember to diversify. Do not put all your eggs into one basket. Okay, so hold multiple skill sets so that you are versatile and you also will be well sought after. Don't aim for money, aim for impact. Money will follow suit. So I would like to invite anyone who might be interested for internship, attachment, postgrad research, or some kind of collaboration in AI, data science, or software engineering in the domain of medicine or health. Okay, you can maybe drop me an email and then we can discuss more. All right. So with that, I end my segment, and now I will hand over to Mr. Ko Wai Kin to carry on with the next part.
Hello everyone, my name is Wai Kin. Today I'm going to share about intelligent stroke rehabilitation system. This is the agenda for the sharing. I will briefly talk about the project and then followed by discussing our system, and finally we will have some video and photo sharing. Let's start. Stroke occurs when a blood vessel that carries oxygen and nutrients to the brain is blocked. When that happens, part of the brain cannot get the blood and oxygen it needs, so the brain cell dies. In Singapore, stroke becomes the fourth leading cause of death. Patients with stroke often experience impairments in motor, sensory, and cognitive functions, which results in difficulties in performing their activity of daily living. Rehabilitation provides the opportunities for stroke survivors to recover the ability to perform ADL. As mentioned by Matthew just now, this project is funded by SG Enable, and we aim to develop an interactive rehabilitation program to motivate users to attend rehabilitation sessions, to reduce the workload from therapists, and to provide the automated home-based rehabilitation system. Following content, I will talk about overview of our system. We did a literature review and market survey, and we found that soft robotic and exoskeleton robotic, they are content-based, which is not suitable for skin allergy user, and they often need calibration, and the system is expensive and bulky. We also noticed that various hand detection projects has been studied by different group of researchers, such as Project Soli from Google, which using ultrasonic for gesture detection, and they claim to have a very good accuracy, while just using Wi-Fi, audio just as well as sound wave using audio signal for hand gesture detection. However, all of these are still in research phase, not yet ready for mass adoption. Virtual reality is gaining popular recently. Gamification with virtual reality has been implemented for stroke rehabilitation. However, according to some research paper, dizziness, headache, and pain were feedback by the user. So we decided to go for infrared camera as it is portable, easy to set up, no discomfort to the user, and it is non-contact to the skin. Finally, it's a very stable product. This is the overview of the system. As you can see from the picture, a Windows-based tablet is used to run the rehab program. Sensors are connected to the tablet through USB port, and a tripod is used to hold the sensor to accommodate the user sitting position, as some of the user might sit on a wheelchair. These are the exercises suggested by therapists. We have rest, pinch, forward reach, rest and supination, weight bearing, up and down large movement, and left and right. This is the user interface of the exercise. As you can see from the picture, this part provides guidance, the white wording, status and progress of the user. The little bear, the AI instructor over here, will show and make audio sound to motivate the user. These are the games embedded inside the system. We have brave bird, fishing, monkey and bananas, doggy and bones, piano, sensitivity, squirrel, and hitting scan. Okay. These are the user interface for the games. The main purpose of this game is to motivate the user to perform more rehabilitation and also to make the rehab session less boring. For the program flow, we implemented decision tree to automate the flow of the program based on the visited session. The exercises, games, and number of repetition to be attended in each session is different. The system also integrated with assessment to track the improvement of the user. The assessment will be carried out at the first and eighth session. These are the results of the assessment. You can see from the picture, the system capture the angles. The system capture the angles of each bone from the fingers, and both the flexion and extension of the finger were recorded. The system produced progress summary at the end of each session. Progress summary allows user and therapists to check the results and track the progress. This reduces the workload from therapists to eliminate recording the result manually, and also allowing therapists to review the result at any time from anywhere. These are some of the progress summary from the Brave Bird and Doggy game. Each dot in the line graph shows the score in each attempt. Next, I'm going to share about some videos and photos regarding this project. We showcase our hand rehab system at the opening of Stroke Support Station at Jurong Point. This is broadcasted at CNA.
From Stroke Support Station will be helping them with the opening of its second rehab center at Jurong Point. A unique combination of gaming elements, artificial intelligence, and sensors also work seamlessly to recover the loss of hand functions. These are part of the rehab process, which include restorative exercises and personalized fitness routines. From Stroke Support.
We also attended some exhibitions and events to promote the system. Okay, just a side note, we are currently running the clinical trial run with Stroke Support Station. For those stroke survivors who are interested, please approach S3, the Stroke Support Station, for further information. Each participants need to attend 2 sessions per week for 1 month. Lastly, thanks for the support for our sponsor and collaborators. That's all. Thank you. Next, I will hand over to the stage to my colleague Meng Yun.
Thank you, Wilkin, for sharing. Let me share my screen first. Okay. Hello, everyone. I'm Meng Yun. Today, I will discuss about melanoma detection application. So here is the presentation outline. First, I will talk about general background of skin conditions, and then I will introduce our melanoma detection application. First is skin cancer. So here I will talk about 3 major types of skin cancer. First, melanoma, which is also our focus today. Then basal cell carcinoma. Next will be the squamous cell carcinoma. Okay, so what is melanoma? Melanoma is a kind of skin cancer. It is also the most serious form of skin cancer. It can threaten people's life if it is not treated. So it also can occur anywhere on our bodies. For its signs and symptoms, we can remember it by 5 points. A, B, C, D, E. So A stands for asymmetry. If we cut the melanoma pattern to half, we can see most of the 2 halves are imbalanced. For its border, it also shows irregular and blood-shaped edges. It also has multiple colors, which usually appears in black, brown, and tan. The color also is uneven and may change over time. But not only changes in color, there is also a change in size. Usually, it will become bigger and spread to other parts of body. The changing process also will be a rapid rate, may over a few months or even weeks. So here is a photo of melanoma. Next is basal cell carcinoma. It is the most common type of skin cancer. It usually occurs in some exposed area of your body, such as neck or face. It can be a pearly or waxy burn, or maybe just a light scar-like lesion. For wounds which bleed or oozing easily and does not heal, may appear again. But unlike melanoma, it is slow-growing and rarely spread to other parts of body. For squamous cell carcinoma, it is primarily caused by years of UV exposure. They are most commonly found on areas of the body that are exposed to the sun, like face, ears, or hands, but they also can develop on inside the mouth, nose, and genitalia. It can be a full and right nodule or just a flat lesion, but may also progress to a wrist bump that continues to grow. Next, I will just share 3 common non-cancerous skin disorders. First is seborrheic keratosis. People tend to get more of them as they get older. And it is harmless and do not need any treatment. So the color of it ranges from light tan to brown or black. The shape might be round or oval, and it is based on look. It also can be a flat or slight raised scaly surface, and the size of it may range from very small to more than 1 inch, and it may cause itchiness. Acne is a very common skin condition, which may be located on the face, neck, shoulders, chest, and upper back. It often triggered by hormone changes and may leave scars or darken the skin if untreated. Lastly, eczema is a common disease among children. It can be a dry, scaly patches on the skin, and affected area may be red, itchy, or oily. It often occurs in people with allergies. Okay, now I will discuss our melanoma detection applications. First, why we developed this melanoma detection application. As I mentioned before, melanoma is the most serious skin cancer, even though it accounts for only a small portion, but it is responsible for most skin cancer-related deaths. The record shows that by 2018, the number of new melanoma has risen to 287,000 in the world. But its survival rate can be high as 91 to 95% if it's detected and treated early. So here are some common and traditional diagnostic technologies. Physical examination or visual examinations, which doctor will examine the area of the skin to note its size, shape, color, and texture, as well as whether there's any bleeding or scaling. They also will examine the lymph nodes, whether they are enlarged, and they may use microscope to examine closely. For skin biopsy, they may also want to see whether it contains any cancer cells, and imaging tests such as CT scan, X-ray, and MRI, they may use to determine whether the cancer scans have spread to internal organs or other bones. So what actually our app is? First, it is a modern smartphone application. Currently, in healthcare system, telehealth becomes an increasing trend, such as telemedicine and telerehab. Mobile health that includes both web-based and the smartphone applications has been increasing use in the management of patients. Common examples are Health Hub and the Health 365 apps. Smartphones can integrate function of monitoring, tracking, memory, and communication to manage personal health. As we can use our smartphone to monitor our heart rate, and some wearables even can monitor our stress levels. Our application also use AI technology. Nowadays, AI is increasing prevalent in our society and begins to apply in healthcare. There are already a number of research studies suggesting that AI can perform as well as or even better than humans at many healthcare tasks, such as diagnosing disease and AI-assisted robotic surgery. Unlike traditional diagnostic technologies, which we may need longer waiting time in the hospital for doctor to do examinations. Our apps simply can be used and assess our own skin condition anytime and anywhere by self-examinations. Last but not least, you will not need to wait like hours or longer time for the lab result to come. Our app will give a faster result, which will be in minutes only. So how our application be developed? As mentioned, we applied novel machine learning and AI technology. Our research engineers use convolutional neural network as a tool in our eyes. It is a class of deep neural networks, and here we use it for medical image analysis. For data source, we obtain data from International Skin Imaging Collaboration 2017 skin image dataset as an example. We also use transfer learning, where we utilize and fine-tune pre-trained CNN for the purpose of skin image analysis. Okay, finally, here are the steps of using our applications. You can scan the QR code provided below, or you can go to the website if you are using a laptop. First, you can read our introduction of melanoma, then you can go to the detection page. Just simply take or upload a photo of your skin which you want to detect, then submit. The result will come with a risk assessment. But to remind you that our application is just a prototype and a demonstration. It is not to use as a proper medical diagnostic. If you have any doubts about your skin conditions, please go and seek professional medical treatment. Well, this comes to the end of our show and tell. Please check our website if you are interested in any courses. Thank you.